Integration by parts is one of the more complicated techniques we will study in this chapter. In this example, integration by parts is applied to the probability question of finding an electron within 3 Bohr radii from the nucleus. The formula for integration by parts is illustrated below. The integral of u dv is equal to uv minus another integral of v du. Now we return to the question, how should you start an integral problem? Number 1, is there a basic integration rule? 2, no basic rule, how about some algebra? 3, how about a trig identity? 4, do you have a composite function? Use u substitution. And now we arrive at the 5th technique for integration by parts. Integration by parts is the product rule of integration. Use integration by parts when you see a product of two non-constant functions. Look for u substitution before using integration by parts. And integration by parts is the reverse of the chain rule for derivatives. The rule for integration by parts is the integral of u dv is equal to uv minus another integral of v du. Unfortunately, almost all textbooks use u and v, which I think is unfortunate if you have handwriting like mine. U's and v's can be mistaken for one another, so be very careful of your penmanship. Here are some guidelines which should help you begin an integration by parts problem. First of all, choose u to be one of the two functions that are being multiplied. Secondly, u will be the function whose derivative is simpler than the function you started with. Third, dv will be the other function combined with dx. And last, dv usually contains a complex function that can be easily integrated. And once again, I'm going to ask you to pause the video and take a look at these 7 problems and determine which technique you should start with. Should you start with a rule? Should you use u substitution? Or should you resort to integration by parts? Again, please pause the video, take a look, and determine which one of these techniques you think we should use. And here are the results. Number 1, the integral of x sine of x squared dx is u substitution. Number 2, the integral of x sine of x dx is integration by parts. 3, the integral of sine of x dx is just a rule. Likewise for number 4, the integral of tan of x secant of x dx is just a rule. Number 5, the integral of the natural log of x dx is integration by parts. 6, the integral of x squared e to the x dx is integration by parts. And last, number 7, the integral of x e to the x squared dx is u substitution. If you got all 7 correct, you should be very happy, as one of the 7 is particularly tricky. Let's take a look at how each of these problems should have been solved. Number 1, the integral of x sine of x squared dx is a u substitution. We're going to let u equal x squared, then du is equal to 2x dx, and we certainly need a 2 in this problem. So the integral of x sine of x squared dx is equal to 1/2 sine of x squared 2x dx, where we put that 2 in the inside of the integral and 1/2 on the outside. This now by substitution becomes 1/2 the integral of sine of u, because u is x squared, du, because du is 2x dx. Now we can use the integration rules to get negative 1/2 cosine of u, which then is equal to negative 1/2 cosine of x squared plus c, because we substitute the x squared back into the u problem. Now let's take a look at problem 2, the integral of x sine of x dx. Here we are going to use integration by parts. First, we'll let u equal x, then du is equal to 1 dx, or simply said, du is equal to dx. And at this point, you should notice that u substitution would not have worked. Now we'll let dv equal sine of x dx, integrate both sides, and we have the integral of dv is equal to the integral of sine of x dx. Or the integral of 1 dv turns into v, and the integral of sine of x dx turns into negative cosine of x. So in conclusion, v is equal to negative cosine of x. Now we pull out the rule for integration by parts. The integral of u dv is equal to uv minus the integral of v du. So the integral of x sine of x dx is equal to x, because that's what u is, negative cosine of x, because that's what v is, minus a new integral of negative cosine of x, because that's v again, and du turns into dx. So in conclusion, we then have the integral of x sine of x dx is equal to negative x cosine of x plus another integral of cosine of x dx. But we have a rule for that. So the final answer is negative cosine of x plus sine of x plus c. Now hopefully you've had your rule sheet out this entire time, because problems 3 and 4 are just rules. Problem 3, the integral of sine of x dx, is simply negative cosine of x plus c. Number 4, the integral of tan of x secant of x dx, is simply the secant of x plus c. And now we're done with both 3 and 4. Problem 5 is a little tricky. It's an integration by parts, where we have the natural log of x dx is integration by parts because in between the natural log of x and dx, there's a multiplication symbol. So we're going to let u equal natural log of x, which forces du to be 1 over x dx, or simply said, du is equal to dx over x. Then we'll let dv equal dx, then the integral of dv is equal to the integral of dx because we integrate both sides. And we have the integral of 1 dv turning into v, and the integral of 1 dx turning into x. So in other words, v is equal to x. Now we pull out the rule for integration by parts. The integral of u dv is equal to uv minus another integral of v du. Returning back to the natural log of x dx, we get that equaling natural log of x, because that's what u is, x, because that's what v is, minus a new integral of x, again that's what v is, and dx over x, because that's what du is. Now we take a look and say, let's simplify. Natural log of x dx is equal to x natural log of x, that's already finished, minus, now we can cross out the x's in the integral above to get the integral of 1 dx, which is very simply x. So the final answer is x natural log of x minus x plus c. Now for number 6. The integral of x squared e to the x dx is another integration by parts problem. We're going to let u equal x squared, then du is equal to 2x dx, and let dv equal e to the x dx, which if we integrate both sides, the integral of dv is equal to the integral of e to the x dx, or the integral of 1 dv turning into v, and of course the integral of e to the x is always e to the x. Now using integration by parts, the integral of u dv is equal to uv minus the integral of v du, or going back to the original, the integral of x squared e to the x dx is equal to x squared, because that's our choice of u, e to the x, because that's our choice for v, minus a new integral of e to the x times 2x dx, where v is equal to e to the x and du is equal to 2x dx. So at this point, we have the integral of x squared e to the x dx is equal to x squared e to the x, which is finished, minus pulling a 2 out, the integral of x e to the x dx. And now what do? Well, if you take a look at it, it looks like it could be another integration by parts, and indeed it is. We have to do integration by parts twice. Isn't that a lot of fun? But this can continue just like it did before, and it will have a very, very long answer. Number 7. If you notice that number 7 looked a lot like number 1, that was a great observation. Because if you let u equal x squared, du is then 2x dx, you need a 2, whether that's in problem 7 or in problem 1, and you can solve problem 7 just like you did problem 1. So in conclusion, let's return to the rule for integration by parts. The integral of u dv is equal to uv minus another integral of v du. So please note that you are never done in one step. And again, the guidelines. Number 1, choose u to be one of the two functions that are being multiplied. Number 2, often u will be the function whose derivative is simpler than itself. Number 3, dv will be the other function combined with dx. And lastly, dv usually contains a complex function that can be easily integrated.